Now let's look at the second type of annuity, which is known as annuity due. Now in this type of annuity, the payments are made at the beginning of each period. So let us look at an example to understand this in detail. Suppose that a sum of rupees 100 is deposited in a savings account at the beginning of each year for 4 years at 6% interest. Find the amount received at the end of the 4-year period. So here the amount of rupees 100 is deposited in the bank at the beginning of each year for 4 years. So let's draw the time scale. So this is 0, 1, 2, 3 and 4. So at the beginning of first year, the outflow is 100 rupees. At the beginning of the second year, again the outflow is 100 rupees. At the beginning of the third year, again the outflow is 100 rupees. And at the beginning of the fourth year, again the outflow is 100 rupees. The rate of interest is 6% per annum for each of the years. So now this amount which has been deposited at the beginning of first year will accumulate compound interest for the next 4 years. This amount of 100 rupees deposited at the beginning of the second year will accumulate compound interest for the remaining 3 years. This 100 rupees deposited at the beginning of the third year will accumulate interest for the remaining 2 years, and the 100 rupees deposited at the beginning of the fourth year will accumulate interest for 1 year. So let's calculate this amount. So let's first take this 100 rupees. Now the formula for compound interest is the total amount is equal to the principal into 1 plus r by 100 to the power n, where r is the rate of interest per compounding period and n is the number of compounding periods. P is the principal amount. So P here is 100. So we have 100 into 1 plus r is 6. So 1 plus 6 divided by 100 to the power n. N is 4 because this is a 4-year annuity. So this is 100 into 1 plus 0.06 to the power 4, which is equal to 100 into 1.06 to the power 4, and this is equal to 100 into 1.2625. So this is equal to 126.25 rupees. So this amount of 100 rupees will become 126.25 rupees at the end of 4 years. Now let's move to the second installment of 100 rupees. So this will accumulate compound interest for the remaining 3 years. 1 plus 6 by 100 to the power 3. So this is equal to 100 into 1 plus 0.06 to the power 3. This is equal to 100 into 1.06 to the power 3. So this is equal to 100 into 1.191, which is equal to 119.1 rupees. So this is 119.1 rupees. Third is this amount of 100 rupees, which is going to grow for the remaining 2 years. So 100 into 1 plus 6 divided by 100 to the power 2, which is 100 into 1 plus 0.06 to the power 2. This is equal to 100 into 1.06 to the power 2, 100 into 1.1236, which is equal to 112.36 rupees. So this becomes 112.36 rupees. Now we'll take the fourth installment of 100 rupees. This will grow for 1 year only. So 1 plus 6 by 100 to the power 1. 100 into 1 plus 0.06. This is 100 into 1.06, which is equal to 100 into 1.06, which is 106 rupees. So the addition of these four figures is what we will get at the end of 4 years based on this investment schedule. So the total is equal to 463.71 rupees. So basically what we did here was the future value at the end of 4 years was equal to 100 into 1 plus 0.06 to the power 4 plus 100 into 1 plus 0.06 to the power 3 plus 100 into 1 plus 0.06 to the power 2 plus 100 into 1 plus 0.06. So basically the addition of these four. So this is what gave us the future value at the end of 4 years, which we got here as 463.71 rupees. Now let's try to generalize this expression. So let me remove these calculations and we'll try to generalize this expression. So let's say we are trying to find the future value when an annuity is being deposited for n number of years. So future value for n number of years. Now here 100 is the amount which is being deposited every year. This 100 typically in a compound interest formula is the P, which is the principal. But in case of annuities, this principal is denoted as A. So let's say this is A, 1 plus. Now this is nothing but R divided by 100. And let's consider R divided by 100 equal to I. So I. Now 4 is the same as N. So N plus again A into 1 plus I to the power N minus 1 plus A into 1 plus I to the power N minus 2 and so on up to A into 1 plus I to the power 1. So let's say this is our first equation. Now let's multiply the left hand side and the right hand side by 1 plus I. So multiply both sides by 1 plus I. So then we'll get 1 plus I into FVN is equal to, now every term will get multiplied by 1 plus I. So now we know that x to the power n into x to the power 1 is x to the power n plus 1. So basically a into 1 plus I to the power n multiplied by 1 plus I to the power 1. So this will become a 1 plus I to the power n plus 1 plus, now for the second term, n minus 1 plus 1. So minus 1 plus 1 gets cancelled, so n. So a into 1 plus I to the power n and so on, plus a into 1 plus I to the power 1 plus 1, which is 2. Let's say this is our second equation. Now let's subtract 1 from 2. So subtract 1 from 2. So all the terms in the first equation will get a negative sign. Minus, minus, minus. So now the left hand side becomes 1 plus I into FVN minus FVN. So 1 plus I into FVN minus FVN is equal to, now this term gets cancelled with this term and so on, and also in the first equation there will be a into 1 plus I to the power 2, so this will get cancelled with this term here. All these will get cancelled. So after cancelling all these, what we are left with is a into 1 plus I to the power n plus 1 minus a into 1 plus I to the power 1, which is the same as a into 1 plus I. Now let's open the bracket. So 1 into FVN plus I into FVN minus FVN is equal to, here we can take a into 1 plus I as common, so we get 1 plus I to the power n minus 1. Let me delete some of this to continue with this calculation. So now let's continue. So here 1 into FVN is FVN and minus FVN, so these two get cancelled. So or I into FVN is equal to a into 1 plus I into 1 plus I to the power n minus 1, or FVN is equal to a into 1 plus I into 1 plus I to the power n minus 1, and we'll bring this I on the other side, so divide by I. So this is the formula to calculate the future value of an annuity at the end of n years in the case of annuity due. Now remember that in the case of the other type of annuity, which is ordinary annuity, the formula is pretty similar, and the only difference is that it does not have 1 plus I. So the ordinary annuity has the formula future value after n years is equal to a into 1 plus I to the power n minus 1 divided by I. So if you compare, only this part 1 plus I is different. Now using this formula, let's calculate the value at the end of 4 years for this example. So here a is equal to 100, I is equal to 0.06. N is equal to 4 because this is a 4-year annuity. So let's plug in these values in this formula. So FV4 is equal to 100 into 1 plus 0.06 into bracket 1 plus 0.06 to the power n, which is 4 minus 1, divided by I, which is 0.06. So this is 100 into 1.06 into, now let's calculate this bracket. So this is equal to 4.3746. So this comes out to be 463.709, which can be rounded out to 71 rupees. So this is the same answer as we got here using the elaborate calculation method. So this is how you can calculate the future value of an annuity due.